Hello and welcome to Let's Unbound, episode number 10. I love maths, but trigonometry is a topic that often confuses everyone. So it does to me also. Why it happens with trigonometry only? Because trigonometry is a combination of various identities, formulas, or relationship between six trigonometry functions included for us to remember. Now, considering so many reasons to hate trigonometry, I have bring one reason for you to love trigonometry. Here is a super trick for you, which is super hexagon. So for super hexagon for trigonometric identities, first of all, you have to normally make a hexagon figure. Then you have to connect all the diagonals. Here you can see, like in this figure. Now here you can see there are six trigonometric functions on the sides, right? Well, what are the use of this? We are going to place each one of the trigonometric function to the edge of a hexagon. But before that, we need to do one more thing. Where all the diagonals meet, we need to label it as number 1. So spot the middle as number 1. There is something written at starting point. Now, always remember when we are placing, remember we are going to place each trigonometric functions, arrange them on the edge of hexagon. So how we are going to arrange them? We are going to take a starting point. So I'm going to take this starting point, and remember, we are going to label every function according to clockwise direction. This is a very important point to remember. Starting from here, you will go to the next point, then to the next, and then to the next in the clockwise direction. So here you can see that I have placed 3 trigonometric functions. Now the starting point was this one. So this is placed as 10. Next is as sine theta, and third one as cos theta. Now if you're not able to remember from where trigonometric function do we need to start from, always remember this sequence. That's so cool. So for that, so cool, T is for 10 theta. So number 1 will be for 10 theta. S for so will be for sine theta. And cool C will be for cos theta. We are left with 3 more. So how we are going to place them? First of all, we are going to see right and left. On the right side, you can see that all the functions which are placed on the edge are starting from co, right? So in the right, all the functions are placed who are starting with co. Now here, in front of chord, you can see that there is a function 10. So take a t from this. So t and t is a common. Cot theta would be placed just in front of 10 theta. And then we are left with cosec and sec. Start from co, so it will be on the right side. Now we are left with sec theta. So put the remaining part over the remaining edge. So here the first identity is the reciprocal identity. It means that all the diagonals. Let's take an example of 10 and cot. So each of the function is reciprocal of the function of their diagonal. So it means 10 and cot are connected with the diagonal, right? So 10 is the reciprocal of cot theta, and cot theta will be the reciprocal for 10 theta. Vice versa, it's going. Just like that, 10 and cosec, sec and cos, like this. So here is for the next diagonal, which is cos and sec. Circle identities. It's saying that you can take any 3 functions one after one. We have taken 3 functions one after one along the edges of superhexagon, and then we will receive an identity of 3 consecutive functions. Now you can see these are going in a sequence. So we are going to receive an identity. We are going to write 10 theta. Then we are taking sine and cos in the similar color circle. So I have written sine as the numerator and cos as the denominator. Now you can go on like this, take three consecutive functions one after another through the edges of super hexagon. Keep on going and make all the possible formulas. Now there's one more thing to remember. What if you make the arrow in this direction, which will be an counterclockwise direction? So for that also, the formula will work as the same. You are starting with cos theta. You're going to write cos theta, and then sine will become the numerator and 10 will become the denominator. Now here is one more possible formula that I have told you. Just like that, here we are going to start with sine theta, and then we are going to take cos theta as the numerator and the cot theta as the denominator. This is not it. You can make so many formulas with that. Product identities. So for this identity, remember, we have labeled the meeting point of the diagonal as 1. So here the diagonal was this, and then the cot theta was the edges of the diagonal. So we are going to use tan theta and cot theta, which are the edges of same diagonal. We are going to multiply them and receive the product as 1. That the same has been done for all the diagonals and for all the functions. Relationship between complementary angles of trigonometry functions. What happened in this? You can see that I have made some parallel lines like this. So it means that all the parallel lines we are drawing, we are going to get the complementary identities here as follows. So if I'm going to draw a line over here, the parallel line, the sine theta will be the complementary of cos theta, which will be written as sine theta is equals to cos 90 minus theta. Same goes for tan and cot, which will be tan theta is equals to cot 90 minus theta in the brackets, and then again goes for sec and cosec theta. Let's move to next identity, which is Pythagorean identities. Here in this identity, you will be able to see three blue triangles right over here. For each triangle, let's suppose we are taking this triangle, we are going to start a clockwise circle from top left corner. From the top left corner, which will be like this, and it will go like this. If we are going to go from clockwise circle direction from top left corner, we are going to receive an identity in the form of square of the first function added by square of second is equals to the square of the third one. So let's first take first triangle, which will be for this. Now you must be wondering, where is the third side? So the third side is this one. Okay. So how we are going to take this? Let's see only the top corner. So in this triangle, we are going to start with sine. So sine square. Then we are going to take the second number, which will be the cos square. And the third, which will be 1. So it will be 1 square, which is equals to 1. That's it for the first triangle. Now let's see for the next triangle, which is for tan, sec, and 1. Now what happens here? First of all, as I have said you, we are going to start from the top left corner, which is tan theta. So it will be tan theta square. Then as we are moving in clockwise direction, we are going to get 1 as our second number. So we are going to write 1 square, which is 1, which will be our second number. Then is equals to the third number, which is sec theta. That's it for today. Thanks for watching. Keep watching us. Like, share, and subscribe.